Okay, this is homework number 5, and this is a benchmark review. So, it'd be very important that we do the best we can on this homework. Let me get real quick, get some things situated. Number 1 says that Maddie is standing 9 feet behind Eleni, and Maria is standing 6 feet to the right of Maddie. What is the distance from Maria to Eleni? So we're looking for a distance, all right? So let's just kind of draw a picture out that we got really quick of what we got going on here. So Maddie is standing 9 feet behind Eleni. So I'm just going to put an A for Eleni, and then MD for Maddie. Okay. So she's standing 9 feet behind. So like that. We'll label that 9 feet. Now it says Maria is standing 6 feet to the right of Maddie. So Maria is standing 6 feet to the right of Maddie. So we're going to put like an MA for Maria there. And let's draw that line of what we got going on. So from there, we'll just say 6. So we'll kind of connect that like there. All right. So we'll label that one 6 feet. Okay. So we got 6 feet there. I think y'all can see what I'm doing here. And it wants to know the distance from Maria to Melanie or to Eleni. So I'm going to put this line in blue. Okay. We'll put this line in blue for us. What we're looking for. So we're looking for the distance about, that distance in blue there. Okay. You can see the right triangle we have. So basically all we're doing is Pythagorean theorem for that. Okay. Okay, number 2 says to write an algebraic representation of the dilation shown below. So this is just like what we did on the homework. Okay, so the exact same concept that we're doing. All right. I'll highlight in red the new image. It goes like that. Okay, the bigger one. In red. And then in green, the original image. So it's going from the smaller diamond-looking shape to the bigger one. All right, find the scale factor, write the algebraic representation. All right, number 3 says a sphere has a diameter of 4 5/8 inches. What is the volume of this sphere? So we're looking for volume. Okay, right off the bat, 4 5/8. I'm going to change that to a decimal. So 4 5/8. 4 5/8, like so. We're going to use 4.625. All right, it's a sphere. That's the diameter, so we're going to have to divide that by 2 to get the radius. Okay, so before I start out, well, actually, let's write the formula for sphere first. The formula for sphere is 4/3 pi times the radius cubed. Very important that you're looking right here. This is cubed, okay? A lot of y'all are putting the square there, so don't forget that. All right, so we need to find the radius. This is diameter, so we got to divide this by 2. So let's go ahead and do that. All right, we're going to get a radius. We're just kind of, round this off a little bit. We'll use the radius of 2.31, we'll say. All right, so that's the radius we'll use. Plug it in the formula, get your answer. Number 4 says to find the mean absolute deviation of the data set. Okay, so mean absolute deviation. And our data set's 10, 7, 13, 10, and 8. So this is like what we did on Friday and Thursday of last week where you're going to find the average. Okay, find the average. You'll divide it by 5. So you'll add them all up, divide by 5. Then you're going to find the difference between that average and each number there. Once you find that, then you're going to find the average again. So, okay, number 5 says to find the volume of the cone shown below. So the volume of the cone, I know is the formula for volume of cone V, oops, V equals 1/3 area of the base times the height. Now we got to find the area of the base, which is pi times the radius squared. All right, so since we do need the radius here, we're given this diameter of 8, and it goes all the way across. So the radius that we will use is 4 because it's half of that. Okay? All right, number 6, again, find the mean absolute deviation, okay, of the data set. All right, so basically find the average twice, just like earlier. Okay, number 7, calculate the distance from the bottom of the wall to the top of the ladder from the picture below. So what I'm highlighting here is what we're looking for. All right, you can see the right triangle. So this is going to be a Pythagorean theorem question again. You just got to figure out if you're going to do a squared plus b squared or c squared minus a squared. All right, number 8, calculate the lateral surface area. So it tells us exactly what it is we're looking for of the triangular prism below. So lateral surface area, remember, all we're looking for is the perimeter of the base multiplied by the height of the base. I know that this is a triangular prism, so my base is the triangle. So if that's my base, then that 10 between the two bases is going to be my height. So just find the perimeter and multiply times the height. Okay, number 9, what is the surface area of the triangular prism below? It says triangular prism, but that's supposed to be rectangular prism, obviously. So the total surface area, remember, is perimeter of base times the height of the prism plus 2 times the area of base. All right, so you just got to find those. It's a rectangular prism, so you can use different you can use a different set of bases. They're not all wouldn't be the same. Okay, number 10, lastly, calculate the distance of D line segment DB from the picture below. So we're looking for this line segment there. Whoops. There we go. All right, I'm given this measurement here, 36, and this is 18. That's supposed to be meters. It got cut off. So 36 and 18. So if I'm looking here, that's really, I'm just looking for this diagonal, so that's a hypotenuse. This right here makes the right triangle. So like if you want to kind of label that with a little right angle in there, you can. So just another Pythagorean theorem question.